Okay, well I'm back. I had a little mishap on the disassembly of this music box. I um, I ran out of room in my phone, my storage, and it cut it off short. So you didn't get to see much of anything about what I'm doing to this governor right here. I don't know if you remember, this went on here with the wheel like this and all. So, but anyway, I'm just going to pick up right here on this one. I'll probably do another one later to and get it all on there and get some storage somehow. But I've got my gears out here. This is a little worm gear that this is what drives the fan. I've got it out because these bearing holes that hold the gears in there are warm. This gear goes in here like this, and it drives this little worm gear. Which drives the music box. Actually, the music box is doing all the driving from the chain out on the end of this little chain gear right here. You can look at the case and see. So we're going to get this cleaned up, and I've already run it through the ultrasonic. So what we do is we take these toothpicks and we jam them into those holes. I don't know if you can see that little black on there. There's cruddy oil just about pressed into the brass almost, and so I'm putting a lot of pressure here and twisting it, turning it, and getting, see, that's the second round, and it's got some dirt on it too. And toothpicks are cheap, so we use a lot of them. You get those holes as clean as you can. And on these, it really doesn't matter because I'm going to bush almost all of them. But any hole that doesn't need a bushing really needs to be cleaned out good, because the pivot is going to be riding back on that same material, that brass. So we're just going to peg these out. We're calling it pegging them out. Pegging out the hole. Okay. I'm going to go blow this out with some air. Okay, so then what we've got to do is, here are these are my hand reamers. And what a reamer does is, these little reamers, and we're going to be putting these, see, these are my little reaming tools. They're flat on this one side. It's actually that diameter sliced in half, and it causes sharp edges to come up on here. And when you stick this, when you put this in a hole, this wedge part, it just starts to open up that hole. You can turn either way, and so that one's too big, of course. So what we're going to use is this little bitty small one, because we've got really small little pivots right here. So what we're doing is we're going to make these holes bigger. This is the one we're going to use. It's 100. It's actually 1.2 millimeters in diameter. I don't know if you can see that. Hopefully you can see that. And it's a cylinder sliced exactly in half, and then that just becomes a knife. And it's got a little shoulder here pin that slides in there, and you can turn it, and then you turn that. So that's the way that's going to work. So what we're going to do now is these are my bushings, and these are the same diameter as this reamer, maybe just a little bit bigger, very minute size bigger, so that when we ream out these holes, in fact, let's see if I can just go ahead and do this one. And you want to keep it perpendicular to everything, straight as you can. And when the force of the weight is pushing on these holes, I don't know if you can see this one, but you can see how oblong that hole is. It's egg-shaped because the gear that's driving it is pushing it in one direction, and so it's holding a force against it in that direction at all times, and it's turning. So it just whittles out a little point out here, gives it an egg shape. So we have to correct that. That's the purpose of making this hole bigger. We're trying to get this reamed out, keeping the center spot of where the factory put the center of that hole. We want to keep that so that when we push the bushing in there, that hole is going to be centered right where the company that made it had located it to be. So we got this one right here, and then you want to make sure you know which direction that is. In fact, I have not paid good enough attention, so let's go through that a little bit. This wheel right here is turning. It's being turned by this wheel, like this. Okay, and so since this is going this direction, this wheel is going in this direction. And since that wheel is going in this direction, this gear is going in the opposite direction, which is this way. So it's going this way. So this gear is pushing. Let's see, this one's going this way. This way. This is going this way. This way. So it's pushing up. It's pushing up. And that's what it looks like to be true in my hole here. The little egg shaped is in the up position. So we're going to go with that. So what we do is put where this is split in half, we put the blade of it in the right where it was worn, right where the little egg shape is. Okay, and then we want to start cutting some of the brass out. Doesn't matter which way you go, but you're going to want to give it a little force. Make sure it's relatively square, and then you want to push in this way with your hand and and you go halfway. Clean that out, and then we're going to go back in that same hole. Same way, only we're going to go the other direction halfway. Okay, and I can see from here I'm a little bit closer back to center here. So I'm going to keep doing that and watching. I'm going to go halfway again, get some of that. I'm trying to take off of this side of the hole because it was oblong, you know, the egg shape was that way. So I'm going to put it back in there halfway, and I'm going to put pressure, and I'm going the other direction. I'm making a half a turn and scooping out some of that brass. I can see I need to do that one more time. And I'm trying to keep everything perpendicular, square to my work here, this piece. Okay, get a little more there. Then I'm going to go back the other way again. I'm putting force this way and scooping some of that brass out of there. I'm getting pretty close. I could go a little bit more, but it's sitting real critical on this. In this application, it is when you're doing a plate, when you're doing a clock plate. It's critical. It's critical that these holes end up in the center from where they were from the factory. Because this one had some egg shapes too. This one was bad. This right here, the escape wheel, which is the heart of the clock, the tick-tock of the clock, is this escape wheel. Yeah, this one down here, the chain wheel that had the chain driving it. So that's critical. But this right here, it's not too bad. Okay, so I've scooped out. The purpose of just going halfway is so I'm only cutting that side of the hole. I only want to cut the side of the hole that was not worn. Okay, now I've got a pretty good round hole, and I think it's pretty centered. So now I can just start driving on in. I can just start, and I'm trying to keep it perpendicular here to get a nice straight hole, so that we get a nice straight bushing in there for the nice straight pivot that it's going to be riding in it. So I'm watching. I'm looking for square this way. I'm looking for square this way. You know, square to this. A right angle to this plate. If that makes any sense to you. Okay, so I'm going to go on in with it. I go in each direction a little bit. I'm watching to try to keep it straight. Okay, I'm starting to break through. Okay, there I am. All the way through with my reamer. Okay. Looks pretty good and straight. See, I'm pretty square that way. Not too bad that way. Okay, so now I take that out, and I've got a hole the size of my reamer in here where my bushing goes. Now for the bushing, what we're going to do is find one, since we know that this right here is the pivot that we're working with, because that's the one that rides up there to drive that worm gear. So we're going to go with that one. We're going to look in our little box here and try to find one that fits on there. Oh, a lot of them go flying, like that one. And no need to even look for it, which I always do. But when they fly off like that, oh, there it is. When they fly off like that, you rarely find them. I think this one was a little bit small. Oh, yeah, I did it again. Okay. It was a little small anyway, so let's try it. Now that one's big. I may have to ream this one out a little bit because I don't have any. I don't really want to make that any bigger. That hole, that reamer. I won't go in there. What we need to do is make sure if I used that one and reamed it out, it's got to be some brass left, or else we're not doing any good. So we're 120 on the outside diameter of this, and that would leave an inside diameter of only about 80. And so that then from 80 to 120, that would be 40. Actually, 20 would be the thickness. Let's see. Just say that was going to be 80. So 40 of that would be half. And then you'd have to half that again. That would make it 20. So the wall of our bushing would only be that. That's not enough. Okay, so what we're going to have to do is go to the next size reamer, which is 180. It's 180 1.8 millimeters in diameter. If I can find it here, here it is. Here's my 181, I call it my 180, 1.8 millimeter reamer. So we're going to go on in there and ream this on out to that size so that we can use one of these larger bushings over here. See, that's not too bad there. I wish it was just a little bit smaller, but it's not. But over here we have some that are smaller. It does have a smaller hole. And I think this one's going to be alright. Let's have another look. I'll put it on there. Then you want to see how much it flexes around on there. Yeah, that's pretty good. By the time you stuff it in that hole, that'll make it even a little bit smaller. So we're going to go with that. So we've already got a round hole. So all we have to do is ream it out larger and do the same thing. Be careful not to squeeze this thing too hard. We're going to stay perpendicular, but now we just got to go with it. We can get jiggy with this one and just go and ream that hole out. And not to the next size bigger. And then that way we can use that larger bushing and have plenty of brass left on our sides of our bushing bearing point, because this bearing, not too much force, but it is bearing force. That's why it's walled out. So I'm watching, trying to keep it straight. We want our bushing to be straight in that hole. Square with the world, as my uncle always used to say when we were building houses. Is it square with the world? Yes, sir. Okay, it's good then. You can go this way if you want to, it doesn't matter. Just be careful, don't don't try to squeeze against your fan to hold it, because it will break the pivot off and you'll be in trouble. If you can even find one of these governors, it's probably very expensive. And I don't even think you can get a movement anymore. But I'm going on through. That hole should have already been centered, and it's going to stay centered because of just the way physics work. I'm getting close there. Trying to stay straight. This way a little bit to finish up. Actually, I think I'm hitting the housing this way. I gotta come this way. Nope. Okay, I'm through. Okay, I'm through there. And I still got lots of meat there. That's a little bigger than I wanted to be. Now I couldn't do that here. But luckily, I don't think that. Yeah, that one does need to be pushed. We'll see. Okay, so now what I want to do is kind of get rid of that raised lip. That raises a little bit of a, turns up a little bit of that brass inside here. So I'm going to take my file, and just a little small file here. I'm just going to rub that off. And then I might take this drill bit over here for my chamfer. I'll go with this little bit bigger one. I can just chamfer this over here, and that'll get rid of all of that. See, I'm just cutting that, a little chamfer around the inside of that hole. Now, here's my bushing. And you always want these bushings to go from the inside. Let me get I have a special tool over here. These are parallel jaw pliers. You see how they're always parallel to one another. See that? So that now I can, and these bushings, you'll never be able to see this, but on one side they're shaved off flat. The whole end of it is flat, but on the other side it has a countersunk hole. It's kind of like the shape of a drill bit down in there. It's angled down a little bit, and what that is made for is so that when you put oil in there from the outside, it makes a capillary makes a little pool of oil around the pivot, and it stays there. And you always want that flat side to be on the inside, so that where this gear is riding against it, this shoulder, you want it flat. But on the outside where you're going to be putting the oil, you want it. So you take and put the flat side up right here like this. And you set it there and so you put this flat spot up so that it'll be on the inside toward the gear. It's kind of delicate right here, but you set this up on there, kind of get it halfway square to the hole, and then these parallel jaws will push that thing straight down in there. See that? They pushed it right in there. Nice and flush on the inside. It might be a little bit extruded, but it won't matter a whole lot on this. These are pretty forgiving. It looks pretty good. See, now we got a little, I hope there's not too much glare and from this light. The lighting's not the best in the world yet. Subscribe and like, and maybe I'll be able to get some good lighting one day. But that's the way that works. Now I've got several more of these to do, and I think I'm just gonna go ahead and get that done, and then we'll pick up from there, because you get the idea, and you don't want to watch my clumsy hands do all of these. So but if you have any questions, just make a comment, and I'll do my best to get an answer out if I know it or if I have time. So I'll be back.